I mentioned that you have your original equation, right? A times b to the x, and in this case, you're going to have an a and you're going to have a b, right? Does anybody remember what I called my a and I called my b?
Your b is your base.
Is your base, exactly. B for base.
And your a is your initial value.
Your a is going to be your initial value. All right, and so a few things to note about a and your b is that your a cannot equal to 0, and your a is always going to be the value where x is equal to 0. And I'll explain to that in a little bit once we get down to finding the graph of an exponential function. And your b is always going to be positive, and it is never going to be equal to 1. So an exponential function has to have an exponent that's a variable, right? So it cannot be a constant, it cannot be a number. So knowing that, let's go through these 5 little problems that I picked out for y'all, and let's see which ones of them are exponential functions and which one of them are not. Let's look at 3 to the x. Is that an exponential function?
Yes.
Yes, it is. So 3 to the x, yes, it's an exponential function. Can anybody tell me what my a is and what my b is in this case? My initial value is going to be what?
0.
It's actually going to be 1, right? Or it says a cannot equal to 0. You can't forget that. So your a is going to be 1. In other words, there's a 1 times 3 to the x. Right? It's very important to remember that your initial value, if you don't see it, is probably going to be 1. Let's try the next one. What about 6x to the negative 4 power?
6 is your a.
6 is going to be your a. Well, yes and no. Let's start off with the first question. Is this an exponential function? It is actually not an exponential function. And the reason it's not an exponential function is why?
Because it's not raised to a variable.
It's not raised to a variable, right? It's in this case raised to a constant. So because it's raised to a constant, it is not an exponential function. Negative 4 is a constant, and it has to be raised to a variable. All right, what about 2 times 1.5 to the x? Angela, what do you think? Yes, you. Yes, it is. And what would be my a and what would be my b?
Your a is 2.
Mhm.
And
1.5, exactly. All right. What about
would the base for b, would the base be 3? Would it be 3?
for this 3 right here?
No. For the first one.
For the
would it be
base.
3?
Oh, yes, sorry, I forgot to go over that. Yes, the base would be 3 in this case. All right, and this next one, the fourth one, we have 7 times 2 to the negative x. What do y'all think about this one? Number 1, is it an exponential function?
Yeah.
It actually is an exponential function. Now, you guys will remember from last class, we did something when we were raising something to a negative power. What was that thing that we did?
Reciprocal.
We took the reciprocal. So this actually looks something like this. 7 times 1/2 to the x power. So what would you say is the base of this, and what would you say is the initial value?
The initial value is 7, the base is 2. Well,
No, 1/2.
The a, which is the initial value, is going to be 7, and the base is actually going to be 1/2. And for the last one, what would y'all say to that one?
it's not.
It is not an exponential function. Why is it not an exponential function?
Because pi is a number.
Pi is a constant, right? This is 3.14, so it is a constant. It's a number, so yeah, exactly. Alright. So once again, we're sort of reviewing what we learned last class. So for practice, I want you guys to go ahead and solve these problems right here. So we have 2 to the 4th, 2 to the 0, and 2 to the negative 3. Go ahead and take like about 30 seconds and see if you can solve those. What did y'all figure out for this one? Yeah, this is equal to 2 times 2 times 2 times 2, which is equal to 16. What about for this one?
0.
No.
It's 1.
Anything to the 0 power is 1. That's what our workshop from last class told us. And this one right here,
It's 1 over 8.
it's going to be 1 over 8. Remember, this negative makes it so that we have to take the reciprocal. Right, so we have 1/2 to the 3rd, and when we distribute that third, we have 1 to the 3rd over 2 to the 3rd. What's 1 times 1 times 1?
1.
And what's 2 times 2 times 2? So that's 1 over 8. Are there any questions on this? Alright, this one's new. F to the 1/2. What do we do there?
Say that again?
F to the 1/2. So in other words, we're taking 2 to the 1/2 power. What does this look like?
Oh, don't you like? Just turn into like square root.
Yeah, actually. So this right here, ladies and gentlemen, what you're going to want to do is follow the equation that states if you have x raised to the a over b, then this is going to equal to the b root of x raised to the a power. What that means is that this right here is equal to the square root of 2 raised to the first power, and this is just equal to the square root of 2, right? Once you simplify that. Knowing that, what would 2 to the 4 over 3 be? So this 3 right here is going to become my what?
It's gonna be inside the square.
It's going to be my root, right?
Oh, wait, no,
So
yeah.
I'm going to take my cube root of my 2 raised to the what?
Four.
To the 4th power. What is 2 raised to the 4th power?
16.
So this is going to be the cube root of 16.
That's it?
You can maybe simplify this, but for right now we're just going to leave it like that.
How would you simplify?
You would take out a perfect cube. So if I wanted to simplify this, I would say that 18 times 2 is equal to 16, and 8 is a perfect cube. So I would take the cube root of 8 times 2, which is going to give you 2 times the cube root of 2.
We're not doing that until later. Right? Too much to worry about.
Alright, let's try this one on our own. We're going to do 2 to the negative 3 over 2. What will be your first step?
Get the negative out.
Get rid of the negative, right? So how do you get rid of the negative? Use the reciprocal. So we said that our first step was going to be to take the reciprocal, which means that we should be at this point right now. 1/2 raised to the 2/3. 3/3, my bad.
Oh, right.
Now what is your next step?
To put it into the square root.
So there's actually 2 different ways you can go about doing this. You can distribute the exponent, or you can take the square root of the whole thing. Let me go ahead and use a post-it to show you both ways. And you guys can choose which way you would like. Actually, I don't have a post-it, so I'm just gonna... No, it's fine. So if we have 1/2 raised to the 3 over 2, like I said, there's two ways we can do this. We can do the square root of 1/2 raised to the 3rd power, or we can go ahead and do we can go ahead and distribute this, so this will be 1 to the 3/2 over 2 to the 3/2. And this is going to be equal to the square root of 1 to the 3rd power divided by 2, the square root of 2 to the 3rd power, right? And both of these should give you the same answer, right? If I were to do this, what is 1 to the 3rd power?
1.
What is the square root of 1?
1.
So it's just going to remain 1. And what is 2 to the 3rd power? 8. So we're just going to leave that as the square root of 8. This one, same deal. If I was to do the square root of 1 to the 3rd power over 2 to the 3rd power, this is just going to be equal to the square root of 1 over the square root of 8. And because you have a square root of a fraction, you can go ahead and distribute that fraction. So that's the square root of 1 over the square root of 8, which is just equal to 1 over the square root of 8. So you see there is no difference between our answers, even though we basically did the 2 steps in different order. Let's go back to this over here. We figured out that our answer was 1 over the square root of 8. Sorry, 1 over the square root of 8. Let's go ahead and go over this right here. So this is asking us to find an exponential function from its table of values. All right. So this one is basically saying, all right, we have a table of values and we know that it's an exponential function, but how do we go about finding it? Well, let's see here. I'm going to look for 2 functions, g of x and f of x. And both of these start off as the original exponential function, a times b to the x, a times b to the x. And our goal is to find out what a is and what b is. Now, the reason we call a our initial value is because it's the value of when x is equal to 0. So let's work with g of x right now, just g of x. What happens when my x is equal to 0? I'm going to go ahead and equal my x to 0. What is the answer supposed to be?
1.
It's going to be 4, right? And so from here, I go ahead and solve for my a. What is anything to the 0 power like we learned last class? This is just 1. So this is a times 1 is equal to 4. And when I divide by 1 on both sides, what do I get?
A equals 4.
A is equal to 4. Now to find my b, I'm going to go ahead and use a different value. I'm going to go ahead and use x is equal to 1, just because that's the simplest one. So I can go ahead and say, all right, so when my a, I found out my a is 4 times b, and my exponent is going to be 1 because I'm using x is equal to 1. And when this is all true, what should my answer be? What does my table say that my answer should be?
4 times 12.
It should be 12, right? So what is anything to the first power? It's just itself, right? So 2 to the first power is just 2, 4 to the first power is just 4. B to the first power is just b. So this is 4 times b is going to give you 12. And so when you divide by 4 on both sides to solve for b, what do you get for your b? 3. In other words, my g of x is equal to 4 times 3 to the x power. Now, for my f of x, we would do the exact same thing. Go ahead and try it out by yourself and let me know if you get stuck, please. What would happen when we had something like this, where we had, let's say for example, x minus 1 squared? What would that do to my graph? What would that minus 1 do to my graph? This right here, this minus 1. Would it move it down? Would it move it up, left, or right? We know that we're adding and subtracting, so it's going to move it, right? It's not going to stretch or shrink it. But is it going to move it up, down, left, right? It's actually going to move it right. Right? Remember, whenever we're inside the parentheses, it's going to move my graph right. So this is actually the same thing that's going to happen here. So if I were to draw my graph, and I draw my parent function with its horizontal asymptote at y is equal to 1. Sorry, y is equal to 0. That's the horizontal asymptote. With its y-intercept at 1, then we would go ahead and just move everything over to the right one. So just little arrows moving out everything over to the right one. So this is going to be my new equation. I'm going to use a solid line for my new one and a dotted line for my parent function. Now in this case, we're either going to be stretching or shrinking. So what do y'all think, ladies and gentlemen? Since we're multiplying, are we going to stretch or are we going to shrink? We're multiplying by 0.5. And it has to be either horizontal or vertical. So which is it? What kind of shrink?
It's gonna be
So here's what I want you guys to think about. First off, if you're multiplying just the x or if you're multiplying the whole number. One of these is vertical, one of these is horizontal. Which is which?
I think, isn't this one horizontal?
This one? This one? You think this one's horizontal?
Yeah.
They're actually flipped. This is the vertical one and this is the horizontal one. So whenever you're affecting just the x, like over here, it's going to be a horizontal movement. It's going to be a horizontal transformation. So in this case, it's going to be a horizontal stretch. That means in my original function, my original graph looks like this. Then my new one is going to look, and I'm sorry I'm not drawing this perfectly, but it's going to look something like that. Right?
Okay, by looking at the equation, how can you tell whether it's going to shrink or stretch?
By looking at the equation. So if we're affecting just the x, so I'm multiplying something. I'm multiplying just the x, so it's basically in my exponent. We know it's going to be horizontal. If it is between 1 and 0, so sorry, between 0, it's 0 is less than x and x is less than 1, then it's going to be a stretch, a horizontal stretch. If it is x is greater than 1, then it is going to be a shrink. Well, and this is the absolute value of x. Now, the vertical one is a little bit easier to understand, right? So just by looking at it, you know that this is going to be a vertical stretch. So in other words, if my original equation was like this, my new equation goes up faster and faster and faster and faster and faster. Right? So this one if my x is between 0, my absolute value of x is between 0 and 1, then it's going to be a vertical shrink. And this one's going to be if my absolute value of x is greater than 1, then it's going to be a stretch. This one, ladies and gents, should be pretty easy for y'all to figure it out. If you guys had to guess, what would you guess that it is? Yeah, this one's actually just going to be a move upwards. So whereas my original one looks like this is going to be a shift up by 1. So even our horizontal asymptote is going to move. And this one right here, this last one, if my original function looks like this, and it's an exponential growth function, what does this look like if we were to find out what its base is, what its initial value was? If we were to simplify it so that we only have positive exponents, what does this look like? Yeah, this is going to be 1/2 to the power of x. And this is actually going to be an exponential decay function. So it's going to look something like this. In other words, it is going to reflect across the y-axis.